Fine. So, good evening, guys. In today's sessions, we are going to discuss about one more algorithm. So, that is one more classification algorithm. So, in the previous session, we have discussed about the different kinds of algorithms, different what is actually machine learning, what are the different types of learning we have, and what are the different types of algorithms or the models that we could have to solve a problem using machine learning tools and techniques. Fine. So, what actually we should just brush out whatever the stuffs we have discussed in the previous session, and let us continue with the next things afterwards. Okay, fine. What is actually machine learning? So, machine learning is just application of artificial intelligence. We can give it like it's a field, it's a branch, it's a subset of artificial intelligence. Right. So, what is actually artificial intelligence is nothing but adding intelligence to the machine so that it can think of its own and it has to react to the real world problems. Okay. So, that is what the artificial thing that you are going to have in future. Okay, so that is what called as artificial intelligence, so that the machine can think of its own thing and can react to the real world, like whatever the actions to be done in the real world, the machine has to take the decisions and it has to think of it, it has to react to it. Okay, so by this mean the intelligence will be added to the machine, and through the series of series of steps, we are going to make the machine to learn the things and to understand the things and to think and react to the stuffs. Okay, so what is machine learning is just a part of that artificial thing. Okay, and what it actually machine learning means, it will just will going to add quite intelligence. Okay, by making the machine to learn the things. Okay, but not in depth. Okay, and machine learning is just like by just briefing the things and finding out the hidden patterns in our entire historical data or the previous data, whatever we are going to give to the machine. So, it will going to understand that basic information, and what is the hidden pattern in that data set, and how the features are dependent one another. So, all these stuff will be learnt by the system by using some specific algorithms, by some specific techniques. Okay. So, thereby it is going to learn the things, learn the situation, learn the information. So, whatever we have given to the system. Okay. So, and there are different techniques, different models, different algorithms will be present in this category, and those will be learned by the system in different ways. Okay, and whatever the data set that we are going to give for the machine will be in a different format, and based on that format, based on that information, the learning techniques will be differed. Okay, so those things we have just discussed in the previous session. Okay, and we can define the machine learning as machine learning is an application of artificial intelligence wherein the system gets the ability to automatically learn and improve based on the experience, whatever the things that we are going to give to the machine. It is going to learn the stuffs or the information that we are going to give to the machine, and it is going to understand that, and it is going to learn that information, and thereby it is going to react, and if that reaction is good, if the reaction is correct, proper, then it's okay. So, otherwise in the upcoming sessions, upcoming reactions, it will going to improvise that thinking capability and reacting modes. Okay, and that is how it will go to understand, and it will going to improve based on the experience, whatever the rewards or the penalties or the punishments that it's going to get. Okay, so based on that stuffs, it will going to improve its performance, improve its learning capability. Okay, that's what the things are which is going to happen in case of machine learning field. Okay, and there are different types of machine learning. So, those are supervised learning, unsupervised learning, and reinforcement learning. Okay, so these are the three different types of machine learning techniques. Okay, so and in case of supervised learning, that we are going to use labeled kind of data. That means we know the output for any kind of input. Okay, if this is the data, what can be this, what can be the output, what can be the prediction, what can be the class, what can be the result. Okay, so that kind of data will be present that in the data set that we are going to give for the machine to learn. So whatever the information that we are going to give to the machine to learn the stuff, so in that data set, in that information, we will be having the information, both the input and the output. What could be the output, what will be the input. So those stuffs will already be there in the information that we are going to give to the machine. Okay, that kind of learning, and based on that data set, based on that information, machine going to learn the stuffs, and for a new sample of data, for a new data set, for the new input, it will going to predict the result. Okay, so that kind of learning will be called as supervised learning. And in case of supervised learning, we'll be having different kinds of problem statements, and these problem statements can be predicting the continuous value or predicting the discrete value. Okay, so these two are the major categories of problems that we could face in case of supervised learning. Okay, so and the machine going to learn, and then afterwards it will going to predict the results in either in the discrete values or in the continuous values. If it is predicting continuous value, then that kind of problems will be called as regression problems, and those will be solved by using the regression kind of algorithms only. Okay, and in case of discrete value prediction, so those kind of problems, like for which problem we are going to predict, the machine going to predict the classes or the categories or the discrete values, that will be called as the classification problem. Okay, and for that problem there is a set of algorithms, there is a set of models that we are going to use them for solving the that kind of classification problems. Okay, for predicting the classes, for predicting the categories, for predicting the labels, so whatever the stuff that you can call, so all means the same. Okay, and all those stuffs will be all these the predictions will be done based on the previous data that we are going to give for the machine to learn. Okay, and in that previous data, in that historical data, or in that learning data set that we are going to give for the machine, will contains, if it is contains in both input and output data. Okay, so that will be called as a that kind of learning will be called as a supervised learning. And in that learning, the machine going to learn under supervision. Okay, under some supervision. Supervision is nothing but whether it is predicting right or it is predicting wrong, whether for this input what will be the output. So those stuffs will be learned. Okay, under known things. But in case of unsupervised learning, what happens here is in case of unsupervised learning, machine uses unlabeled data to learn the things. Okay, here what happens, only input will be present, no output. The machine has to understand the distribution of data. Okay, how the data is distributed, the pattern of distribution, it has to understand by its own. It has to understand something, some stuff, like similar data will be grouped in some way, and for those groups will be giving some, will be getting some results. Okay, so those kind of learning will be called as unsupervised learning. Okay, and in case of reinforcement learning is nothing but like your games. Okay, and where you are going to get the penalties, get the rewards for your actions. Like, okay, the U is nothing but machine. Okay, so machine going to get the rewards, machine going to get the penalties for its actions. If it is doing the right things, predicting right things, and working on a correct data or correct information, proper information, then it will going to get, like, more often it will going to get the rewards. And if it gets the rewards, like it thinks that it is predicting in a right way, and it understood the data set in a proper way, and it continues to understand the same manner. Okay, and if it gets the penalties or the punishments, then it thinks that it's not predicting the right results. It didn't understand the data what it has got in the proper manner, and they are going to correct it, and it will not going to, the chances of repeating the stuff in future will be less. Okay, that's kind of results, or that kind of prediction, or that kind of understanding will be avoided. Okay, in case of reinforcement learning, this is what the stuff that is going to happen. Okay, and These are the different types of learning, and what kinds of machine learning that you're going to have. Okay. And in future, in real world, you're going to see the problems of classification kind, regression kind, or the clustering kind. Okay, so and classification problems are the problems with the categorical solution that we where we are going to we are going to get the results in classes or the categorical way, categorical data, like either discrete values that we are going to get it. Okay, and what happens here is the results will be in a discrete way, discrete solutions. That means either separate classes, either male or female, spam mail or not so spam mail, whether it is a whatever the image that we are going to give to the machine. So it is of animal image or a bird image or a person image, or it is of, if it is of animal, so what it actually, whether it is a cat, it's a dog, it's an elephant, camel, so what it is. Okay, like those stuffs, there's a separate classes, separate labels, separate categories of values will be present, and those kind of solutions will be available as a result of classification problems. And coming to the regression problems, in case of regression problems, what happens here is the solutions will be in a continuous way. Okay, the solutions will be in a continuous way, in the sense the values, whatever the values that you or the predictions that you are going to get as a results from this kind of learning from the machine, and those kind of results will be in a continuous mode, continuous values, like price of a car, predicting the price of a car if it is having certain features, or predicting the price of a house, predicting the salary of a person based on his age and experience, based on predicting the rainfall quantity based on the climatic condition. Okay, so likewise that kind of values will be predicted using the regression kind of problems. Okay, and coming to the clustering problems, here the problems will be using the machine will be using the unlabeled data to learn the patterns of distribution of the data, and thereby it will going to analyze the pattern, what kind of pattern is distributed in the entire data set, and for a similar data set, similar values, similar samples will be grouped. Okay, and these separate groups are nothing but clusters. Okay, so problems wherein the data needs to be organized to find the specific patterns, like the case of product recommendation, like this is what the just a simple example for these kind of problems. Okay, so whenever the, like for example, when a mall, you consider a mall, and the plenty of customers will come and go, and will be having some data that which customer, like every customer will be given with a customer ID, and for which customer ID what kind of products they have purchased. There will be a list of items that have been purchased and for the bill for that, and out of those customers, who will, like how many customers are used to buy more groceries on a particular day, or vegetables on a particular day, or clothes on a particular day. Okay, so thereby it will going to group up, finding out the similar pattern data, like all the customers who is going to buy only groceries will be grouped in some way, grouped in one group, and all the customers who are going to buy the vegetables will be grouped in some other way, and all the people who will going to purchase the clothes will be grouped in one group. Okay, so that kind of group can be happen, or finding out similar, like Monday, only Monday is coming customer, only Tuesday is coming customer, only weekend coming customers. So they might going to categorize in some or the other way, and based on what pattern, what is the key thing that it is going to group up. So learning that stuff is what about you're going to do in clustering techniques. Fine. And coming to the problems that we are going to concentrate today is specifically a classification problem. Okay, so and these classification problems are the problems with like finding out the categories, either yes or no, or true or false, or 1 or 0, mail, spam mail or not, male or female. So these kind of stuff that we are going to predict by using the classification algorithms, and there are plenty of algorithms that in a machine learning field that we can use to solve the problems on classification. Okay, so and that is what here are the some classification algorithms. So those are naive Bayes decision tree, logistic regression, random forest regression, and random forest classification is also present. Okay, so even though name is regression, don't worry about it. So some algorithms are there in the machine learning field, so that the name can be a regression, but it can be used for both the purpose, for solving regression problems and for solving classification problems. For both the purposes, it can these algorithms can be used, but whatever the parameters that we are going to give for these algorithms matters. Okay, so decides which kind of prediction that it will going to give. Okay, and the specific algorithm that we are going to discuss today is decision tree algorithm. So what is actually a decision tree? Okay, and decision tree is a tree shaped diagram used to determine a course of action. So each branch of the tree represents a possible decision or occurrence or reaction. Okay, so in the decision tree algorithm, that whatever the things that we are going to predict as a result is what is all about specific decision, the discrete value or a specific class or a specific category. Okay, or the occurrence or any reaction, specific reaction that it is going to give as a result. Okay. So decision tree is a tree shaped diagram that is used to determine the course of action. That means the entire data set will be analyzed, and the data distribution will be like whatever the pattern is hidden inside the data will be understood by the machine, and it will going to format a tree shaped diagram. Okay, by using that entire data set that we are going to give it to the machine. Okay, so using that data set, it will going to understand and it will going to form a tree. Okay, the machine going to form a tree based on some certain criteria. It will going to create a tree like structure, and in that tree structure, don't worry, all the tree like in that tree structure, whatever the nodes, whatever the points, whatever the edges that it is going to have, will all be present in your data set today. So based on some certain criteria, it will going to apply on the data set, and thereby it will going to prioritize the features, and thereby it is going to find out the specific class. Okay, so what kind of criteria it will going to use to build that tree, and what are the stuffs that it will going to use to be used to build that tree is what is all about the decision tree. Okay, and for this kind of stuff will be learned, and this is what happened in case of decision tree. The machine going to build a tree like structure using the data set that we have given to the machine to learn, and this tree structure will be used to predict the class. Okay, so this is what the stuff it is going to happen in case of decision tree algorithm. Okay, and thereby it will going to identify a like for example, like if you want to identify a random vegetable from a shopping bag, okay, which can be the priority. So that is what the simple example for decision tree, how it will go to decide. Okay, so those kind of stuffs we can learn. Okay, so just consider this example, like how you find out a specific like random vegetable that you are going to get it from a shopping bag. Okay, so which vegetable it is, we will give just a priority, like we will just consider the criteria of color. So is the color is red, so if true, whichever the vegetables are we are going to consider some features. So based on those features, we are going to apply some criteria, apply some strategy, apply some condition. So if that condition is satisfied, whatever the condition is satisfied, like whichever the samples satisfy that condition will be grouped, and some other will be taken one side, and whichever the samples which are not going to satisfy that condition will be taken on another side. And here in this example, like we are going to categorize the fruits, vegetables, and like the first criteria is being the color. So what is the color of the vegetable? So is it red? So if it satisfies this condition, so all will be categorized in one group, and whatever like whichever the variables are not satisfied this condition will be categorized in another side. And if the satisfied will be applied with another condition, like what is the diameter of the particular vegetable. If it is greater than 2, so it will be categorized one section, and if it is less than 2, it will be categorized in another section. So if both are satisfied, so like whatever the conditions are applied, so based on that different classes will be available. So observe here, so this will be like, this cannot be applied with any other condition because all the vegetables here all be same. So this is one class, so here whatever is there, so all will be another class, here whatever is there, so it will be of another class. Okay, so this is how the classes will be created, and for all these classes the naming will be given. Okay, so if this condition is satisfied, this is what the result, whatever the result after applying this condition we are going to get. So this is of vegetable, this particular, so this is of chili, this is of capsicum. Okay, so this is how we are going to get the results from this kind of a decision tree algorithm. Okay, hope you understood. This is just a general scenario. So how this particular data set is considered, how the condition, like based on like strategy or the criteria that we are going to apply here, and how this will be again splitted, and what will be the next criteria, and how this split will be happen. So finally what kind of classes we will going to get. So this is what all about the stuff that will going to implicitly happened in case of decision tree algorithm. Okay. Okay, so what are the different kinds of problems that can be solved by using the decision tree algorithm is both. So we can solve a classification problem, and we can also solve a regression problem. So of course, as I said, today we are going to discuss about the decision tree algorithm. So and specifically we are going to use it for solving the classification problem, but it's not that decision tree algorithm cannot be used for solving the regression problem. Of course it can be used to solve the regression problem also. So as I said in the previous sessions itself, some algorithms will be present, some models will be present in the entire machine learning field, and so some are like in such a way that some algorithms will be used for only solving regression kind of problems, and some algorithms will be present so that they can be used to solve only the classification problems. But some algorithms and another set of algorithms will be present so that they can be used for solving both the kind of problems, either classification or the regression. Okay, so it can be used for both the purpose, but whatever the parameter that you are going to give, and whatever the model, whatever the stuff that you are going to import and use, so it is what all the matter. Okay. And decision tree algorithm can be used for solving both the classification problem and regression problem. Okay. And how the classification problem will be solved? So a classification tree will determine a set of logical if then else conditions to classify the problems, as I said in the previous example. So first whatever the like we are going to give the condition, that is what the criteria, if the whatever the samples, whichever the samples that will going to satisfy that condition will be keep aside, and whatever the conditions that you are going to give will be sampled with will be categorized into another session. Okay, so just a sec. Okay, what kinds of problems that you can solve using decision tree algorithm is like classification kind of problems, and both regression kind of problems can also be solved by using the decision tree algorithm. But what happens whenever you try to solve the classification kind of problem, that means what like predicting the classes or categories or the labels by using the decision tree algorithm. So the classification tree will determine a set of logical if then conditions to classify the problems, like set of like series of if then else conditions will be applied on the particular data set by considering a specific feature, and based on that condition whether the like which sample is going to satisfy and which samples is not going to satisfy will be categorized, and that kind of procedure will be continued further by considering all the features until and unless it will get the specific class as a output, as a end points. Okay, so and whatever like endpoints are nothing but your leaf nodes, and those are nothing but your classes, predictable classes, like what kind of like yes or no. So this should be the node. So until that node will arrive, the classification will keep on continuing, and splitting of the tree and the branches and the nodes, so all those stuffs will be continued further by applying specific like series of if then else conditions on the specific features. Okay, so and for example, discriminating between 2-3 types of flowers based on certain features, like if the color of a flower is red, or petal size is 3.5 centimeter, which is greater than 3.5 centimeter, and which is less than 3.5 centimeter, will be categorized into 2 classes, and out of that based on like next criteria, or the next condition will be like color, or the next condition will be the sepal size, sepal length or width. So like this, like that it will go to apply a series of conditions on the specific features of the particular data set. Okay, so thereby it is going to identify the specific classes by the end of the tree. Okay, and how the regression problems are satisfied. So regression problems are satisfied as like regression tree will be used whenever the target variable is numerical or a continuous nature. Okay, so we'll fit the regression model to the target variable using each of independent variables. Like independent variables are nothing but your features, so we'll fit that entire features to our model, and thereby it will going to split by using that entire data set. It will going to split the nodes or the features or the samples, and each split is made based on some of the squared error. So whatever the error it will be available, so based on that error it is going to split up, and finally whatever the output will be given, so that will be your result. Okay, so and that is that will be in a continuous values. You cannot like it's not like a specific class, it will be a continuous value. Okay, and what can be the advantages of decision tree? And advantages of decision trees, it is very simple to understand, interpret and visualize. Okay, it, like very easy to understand based on certain criteria, certain feature, certain condition, the tree will go to build, and finally whatever the leaf nodes that we are going to get, that will be your result. Okay, by following that criterias. Okay, so next it is little effort required for the data preparation. So not much preparation is needed for the data to give it to the decision tree algorithm. Okay, very little much effort is needed. Okay, and it can handle both numerical and the categorical data, as I said. So we can solve both the classification problem and regression problems by using the decision tree algorithm, so that it can be used for both solving numerical data as well for the classification and the regression problem. And for some algorithms it is needed that we have to convert the categorical data into a numerical data, like we have to perform the encoding techniques, because some algorithms didn't expect the data to be in a categorical way, so that it couldn't calculate the values. So for that purpose we need to convert the categorical data into numerical data. But here what happens in the case of decision tree, it can handle both the numerical data and the categorical data. Okay, and another advantage is non-linear parameters don't affect its performance. Okay, so whatever the non-linear parameters, non-linear in the sense like the discrete values, it can be the like variations values, doesn't affect its performance. Whatever the values it will go to change, so it doesn't affect the performance of the tree. Okay, and what can be the like for any algorithms, some kind of disadvantages will be there, and what are all the disadvantages of the decision tree. So let us see that. Like the main disadvantage of the decision tree is overfitting. Okay, so overfitting occurs when the algorithm captures a noise in the data. Like it is very prone to like overfitting. Okay, because like small changes, small noises will also be captured, so that like overfitting, like no adjustments will be considered for classifying the results. Okay, so like prone to overfit is more in case of decision tree. Okay, and high variance, the model can get unstable due to small variation in the data, because even in the small variations in the data can affect the results. Okay, so that's why it is not like it is very very unstable. Okay, and a low biased tree, like highly complicated decision tree tends to have a low bias, which makes it difficult for model to work with the new data, because like unbiased, like very low biased, some strict restrictions will be there, so constraints will be there, so it is very unbiased, low biased tree. Okay. And the important terms, next we are going to get into the decision tree algorithm in depth, so that we need to understand how this will work. So that for that purpose we need to understand what are all the important terms that we need to understand for solving a decision tree problem, for a problem using a decision tree algorithm. Okay, so and the important terms are entropy. And what do you mean by entropy? Okay, so entropy is a measure of randomness for unpredictability in the data set. That means the entropy is nothing but your randomness. That means for you will apply some criteria, you will apply some strategy on the data set for a particular feature, and you'll get some results. If that results is of a mix of both or multiple classes, okay, like all the I'll apply some strategy, like observe here. Okay, observe here. So there is a set of, for example, here is a data set which contains the different classes of animals, right? So we have giraffes, we have elephant, we have tiger, we have monkey. Okay, so there are a mixture of multiple class values. So on applying some criteria, or on applying some strategy, on applying some condition, we'll get the result like this. So if the result is like this, the data has very high entropy. That means we'll have the mixture of very high mixture of both, like all the possible classes. Okay, so I'll also call it like impurity. Okay, impurity is more, like when the mixture of classes is more, so it is very impure. Okay, so entropy is nothing, is a measure of it. So entropy is a measure of purity of the or impurity of the entire data set. Okay, and the next thing is like we'll just see the example, like we'll have the data set, and we'll apply the condition, like whether it is a color is yellow or not. Okay, so the animals whose color is yellow will be in one category, whose not color is yellow which will be in another category. So this is high entropy. ತುಂಬಾ ಇಂಪ್ಯೂರಿಟಿ ಯಾವುದು ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಸೊ ಅದನ್ನು ಫಸ್ಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಅದಕ್ಕೆ ಕಂಡೀಷನ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಅಲ್ಲಿಂದ ಒಂದು ಕ್ಯಾಟಗರಿ ಮಾಡ್ಕೋತಾ ಬರ್ತೀವಿ. ಕ್ಯಾಟಗರಿ ಮಾಡ್ಕೋತಾ ಬಂದಾಗ ಸ್ವಲ್ಪ ಇಂಪ್ಯೂರಿಟಿ ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ನಂಬರ್ ಆಫ್ ಕ್ಲಾಸಸ್ ಎಷ್ಟಿರುತ್ತೆ, ಎಷ್ಟು ಕ್ಲಾಸಸಲ್ಲಿ ನಮ್ಗೆ ಅವೈಲೇಬಲ್ ಇರುತ್ತೆ ರಿಸಲ್ಟ್ಸ್, ಅದೆಲ್ಲ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಓಕೆ, ಓನ್ಲಿ 2 ಕ್ಲಾಸಸ್ ಇರುತ್ತೆ, 2 ಕ್ಲಾಸಸ್ಸಲ್ಲಿ ನಿಮ್ಗೆ ಟೋಟಲಿ ಇರೋದು 1 2 3 4 ಕ್ಲಾಸಸ್ ಆಫ್ ಅನಿಮಲ್ಸ್. 4 ಕ್ಲಾಸಸ್ ಆಫ್ ಅನಿಮಲ್ಸ್ ಅಲ್ಲಿ ಈಗ 2 2 ಬಂತು. ಓಕೆ, ಕ್ವೈಟ್ ಇಂಪ್ಯೂರಿಟಿ ಇಸ್ ಕ್ವೈಟ್ ರೆಡ್ಯೂಸ್ಡ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ ಕ್ಯಾಟಗರೈಸ್ ಮಾಡ್ತೀವಿ ಹೈಲಿ ಪ್ಯೂರ್ಡ್. ಒಂದು ಕ್ಲಾಸ್ ಅಂತ ತೊಗೊಂಡ್ರೆ ಅದರಲ್ಲಿರೋ ಎಲ್ಲ ಸ್ಯಾಂಪಲ್ಸು, ಅಂದರೆ ಅದರಲ್ಲಿ ಬಂದಿರೋಂಥ ಎಲ್ಲ ಅನಿಮಲ್ಸು ಒಂದೇ ಕ್ಲಾಸಿಗೆ ಸೇರಿದೆ. ಓಕೆ, ಸೊ ಈ ಥರ ಈಗ ಝೀರೋ ಎಂಟ್ರಪಿ, ಫೈನಲಿ ಝೀರೋ ಎಂಟ್ರಪಿಗೆ ಯಾವಾಗ ಬರುತ್ತೆ ಅಲ್ಲಿಗೆ ನಮ್ಮ ಡಾಟಾ ಸೆಟ್ ಟ್ರೀ ಸ್ಟ್ರಕ್ಚರ್ ಮುಗಿಯುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಅವರ್ ಟ್ರೀ. ಹೈ ಇಂಪ್ಯೂರಿಟಿಯಿಂದ ಲೋ ಇಂಪ್ಯೂರಿಟಿ ಅಂದರೆ ಝೀರೋ ಇಂಪ್ಯೂರಿಟಿ ಬರೋವರೆಗೂ ನಾವು ಕ್ಲಾಸಿಫಿಕೇಷನ್ ಮಾಡ್ಕೋತಾ ಹೋಗ್ತೀವಿ. Okay, so this is how the decision tree is going to use these terms. Okay, so likewise, like this entropy, we have so many matrix or the criterias. Okay, different criterias, like entropy is one such criteria, like impurity ಇಂದ ರೆಡ್ಯೂಸ್ ಆಗ್ತಾ ಬರ್ತೀವಿ, ಪ್ಯೂರಿಟಿ ಇಂದ ಆಗ್ತಾ ಬರ್ತೀವಿ. ಪ್ಯೂರಿಟಿ is like purity is measured by using the information or the gain or the Gini index kind of matrix, and information gain is it is a measure of decrease in entropy after the data set is split. ಸೊ ಇನ್ನು ಇಲ್ಲೇನಾಗುತ್ತೆ, ನಾವು ಎಂಟೈರ್ ಡಾಟಾಸನ್ನ ಫಸ್ಟಿಗೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡು ಅದರಲ್ಲಿ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ಆಲ್ ದ ಕ್ಲಾಸಸ್ ಇರುತ್ತೆ, ಲೈಕ್ ಇಂಪ್ಯೂರಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಇಂಪ್ಯೂರಿಟಿನ ರೆಡ್ಯೂಸ್ ಮಾಡ್ಕೊತ ಬಂದಾಗ ನಮಗೆ ಎಂಟ್ರೋಪಿ ಕೂಡ ರೆಡ್ಯೂಸ್ ಆಗ್ತದೆ ಅಂತ. ಅದು ಈ ಎಂಟ್ರೋಪಿ ಎಷ್ಟು ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ, ಓಕೆ, ಸೊ ಅದನ್ನು ನಾವು ಇನ್ಫಾರ್ಮೇಷನ್ ಗೇನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅದನ್ನು ನಾವು ಇನ್ಫಾರ್ಮೇಷನ್ ಗೇನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, similar to the entropy, so we have as like I said, information gain, like information gain is a measure of reduction in the entropy. Entropy is like measure of impurity and how much it is reduced on every split. So that is what your information gain, and this can be be the strategy. Okay, so or the criteria for building up your tree, constructing your tree. Okay, so similarly we have some more strategies like Gini index. Okay, so that is also a measure of purity in your data set, like how the purity is going to take on applying every condition. Okay, and finally you are going to get the leaf nodes. Okay, so specific, and that is nothing but your specific classes, that is your results. Okay. Leaf node carries the classification or the decision. Okay. So this is what it makes the important for calling this name decision tree. We are going to construct a tree based on certain criteria, and finally we are going to get the leaf nodes, which is our decisions, and that decision is nothing but your class. Okay, and this is how you're going to build your tree based on some criteria like entropy or the Gini index or the information gain, and finally you are going to get the leaf nodes, and these leaf nodes are your decisions, and which is the first feature or the condition that you are going to consider will act like a root node, and the topmost decision node is known as your root node. Okay, that's like similar to your tree structure. Top in the bottom, like from the stem, from the roots, you are going to like you will observe normal trees. So firstly we are going to have the roots, after that we are going to have the stem, after that you are going to have the leaves and the branches, right? So similarly, whatever like where it has begun, so that will act like a root node. Okay, so and how does it work actually? Okay, so consider here is just a simple scenario that you can use to build decision tree to solve the problem. Okay, so once a hunter went to like wants to went to a jungle and wants to find out what kind of animals will be present in the jungle, and how which he can choose to hunt. Okay, so he'll think that wonder that what kind of animals will get in the jungle today. Okay, so we'll be having different classes of animals. Okay, so let's try to classify different types of animals based on their features using the decision tree. Okay, just apply that scenario. Okay, so what is the problem statement then? The problem statement states like this: to classify the different types of animals based on their features using the decision tree. Okay, so using decision tree algorithm, you have to classify the different types of animals which will be present in your in our jungle. Okay, the hunter has to classify that. So based on the features, he is going to classify. Okay, so the data set is looking quite messy and the entropy is high in this case. So this is what your data set. Okay, and it is quite messy and the entropy is high in this case because the mixture of classes is more. Not only one or two classes are present, or more, like entire one class is present, multiple classes are present. So multiple classes are present in a data set is nothing but your entropy is more, impurity is more, right? So we'll just consider some training data set. Okay, training data set is nothing but your data to be given to the machine to train like for the learning purpose. Okay, this is what we have considered some features: color, height and label, gray colored, and with the 10 centimeter or the meter height, 10 meter height elephant, and yellow colored 10 meter height giraffe, brown colored 10 feet, like you will consider as a feet, 3 feet monkey, 2 gray 10 feet elephant, yellow 4 feet tiger. Okay, so this is what your training set, so that we are going to give it to the machine, or the the hunter will have in his hand to classify the animals. So how it is going to split? Okay, so we have framed the condition that split the data in such a way that the information gain is the highest. Okay, which criteria or the condition will give you the highest information gain, highest reduce in the entropy. ಎಂಟ್ರೋಪಿ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ಇಷ್ಟೊಂದು ಕ್ಲಾಸಸ್ ಇದೆ, ಇದನ್ನು ಒಂದು ಕ್ಲಾಸಿಗೆ ಬರೋ ಥರ ಅಥವಾ 1 or 2 ಕ್ಲಾಸಸ್ಸಿಗೆ ಬರೋ ಥರ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಆ ಥರ ಕಂಡೀಷನ್ ಅವೇನು ಕೊಡ್ತೀವಿ, ಸೊ ದ್ಯಾಟ್ ಮೇಕ್ಸ್ your knowledge or the decision tree algorithm effective. Okay. So first note you need to keep in mind is gain is the measure of decrease in entropy after splitting. Okay, ಎಷ್ಟು ಮಟ್ಟಿಗೆ ಸ್ಪ್ಲಿಟ್ entropy reduce ಆಯಿತು, that is what your measure. So let's try to calculate the entropy for the current data set. This is what your current data set, and this is what the formula for the entropy. So summation of p of value I log 2 of p of value is nothing but probability of a particular classed elements out of entire set of classes. Okay, so probability of a particular classed element value and log multiplied by log of the probability value to the base 2, and I is equal to 1 to the k takes n number of elements. How many classes will be present, so that many classes will be your value of k. Okay, so let us calculate this. Okay, so we'll be having one class with 3 value, another class with 2 value, another class with 1, another class with 2. So how many total? 8 values are present. That means 8 animals are present. Out of 8 animals, 3 giraffes are there, 2 tigers are there, 1 monkey and 2 elephants. Okay, so we'll just check out the entropy here. Okay, so entropy, 3 giraffes out of 8 animals. So log 2 3 by 8 plus probability of elephant 2 by 8, probability of monkey 1 by 8, probability of tiger 1 by 2 by 8. So any other classes left? No, right? So we'll have all the classes of animals, will have the entropy, and the entropy is equal to 0.571. Okay. So we'll calculate the entropy of the data set similarly after every split to calculate the gain. So we're going to apply the series of conditions and calculate the entropy. So thereby we calculate the gain. Okay, so and gain can be calculated by finding the difference of the subsequent entropy values after every split. Okay. And we'll do that by splitting the data set using the each condition and checking that gain, so that we get out of them whether it is reduced or not, and what will be the different conditions. So we'll just check out that condition and we'll just use them and we'll find out. Okay, so the condition is that gives the highest gain will be used to make the first split. After that, so which is the second, so that will be considered next. So observe here, this is what your series of conditions that you are going to apply, and for that using this data set, this is what your series of conditions. So for which condition the gain will be more, so that condition will be considered first. Okay, so ಇಲ್ಲಿರೋ ಇಷ್ಟು ಕಂಡೀಷನ್ಸ್ನ ನೀವು ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. ಸೊ ಈ ಕಂಡೀಷನ್ಸಲ್ಲಿ ಯಾವುದು ನಿಮಗೆ ಇನ್ಫಾರ್ಮೇಷನ್ ಗೇನ ಜಾಸ್ತಿ ಕೊಡ್ತಾ ಇದೆ ಅದನ್ನು ನೀವು ಫಸ್ಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಾ. Okay, afterwards which is the next, so that will be considered. Okay, so based on that thing we'll be having finally constructed a tree. Okay, so conditions apply ಮಾಡ್ತಾ ಬರ್ತೀವಿ, ಸೀರೀಸ್ ಆಗಿ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಸೊ ಕಂಡೀಷನ್ ಯಾವ ಕಂಡೀಷನ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಮಗೆ ಎಂಟ್ರೋಪಿ ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ತುಂಬಾ ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಇನ್ಫಾರ್ಮೇಷನ್ ಗೇನ್ಸ್ ಯಾವುದಕ್ಕೆ ಜಾಸ್ತಿ ಬರುತ್ತೆ ಅದನ್ನು ಅಪ್ಲೈ ಮಾಡ್ಕೋತಾ ಬಂದು ಇಲ್ಲಿ ಟ್ರೀನ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಫೈನಲಿ ನಮಗೆ ಡಿಫ್ರೆಂಟ್ ಕ್ಲಾಸಸ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಸ್ ಬರುತ್ತೆ. Okay, so we'll be having giraffes here, tigers here, and monkey and elephants on the different sections. Okay, so thereby since every branch now contains the single label type, we can say that the entropy in this case has reached the least value. Okay, so finally ನಮಗೆ ಎಲ್ಲಿಗೆ entropy 0 ಬರುತ್ತೆ ಅಲ್ಲಿವರೆಗೂ ನಾವು ಸ್ಪ್ರೆಡ್ ಮಾಡ್ತೀವಿ. Okay, so and this tree can now predict all the classes of animals present in the dataset with 100% accuracy, right? So that is how your decision tree is going to work. ಸೊ ಈ ಥರ ನಾವು ಫಸ್ಟ್ ಇನ್ಫಾರ್ಮೇಷನ್ ಗೇನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ, ಆರ್ ಎಲ್ಸ್ ಎಂಟ್ರೋಪಿನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೋದು, ಅಥವಾ ಡಿಸಿಷನ್ ಟ್ರೀನ ಇನ್ಫಾರ್ಮೇಷನ್ ಗೇನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೋದು, ಅಥವಾ ಜೀನಿ ಇಂಡೆಕ್ಸ್ ಅಂತ ಇನ್ನು 2-3 ಮೆಟ್ರಿಕ್ಸ್ ಇದೆ. ಸೊ ಅದರಲ್ಲಿ ಯಾವ್ದು ಬೇಕಾದ್ರೂ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೋದು, ಕ್ರೈಟೇರಿಯಾ ಆಗಿ ಯೂಸ್ ಮಾಡ್ಕೋಬೋದು. ಬೇಸ್ಡ್ ಆನ್ ದ ಎಂಟ್ರೋಪಿ ಯು ಕ್ಯಾನ್ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಯುವರ್ ಟ್ರೀ, ಬೇಸ್ಡ್ ಆನ್ ದ ಡಿಸಿಷನ್ ಟ್ರೀ, ಬೇಸ್ಡ್ ಆನ್ ದ ಇನ್ಫಾರ್ಮೇಷನ್ ಗೇನ್ ಯು ಕ್ಯಾನ್ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ದ ಟ್ರೀ. ಓಕೆ, ಸೊ ವಿಲ್ ಜಸ್ಟ್ construct it, and afterwards finally until and unless we get the different classes, so we'll keep on building up the tree. Okay, so I'll just take a scenario of use case loan repayment prediction, just implement that stuff. So this is what your data set will be having, like set of samples. Okay, the rows are nothing but your samples and the columns are nothing but your features. Okay, we have some data set in our hand of a particular customers. Okay, so out of those customers some features are extracted, like for which house number, what is the initial payment, what is the last payment, and what is the credit score. So based on that whether he is going to repay the loan or not, so we are going to predict that. Okay, so based on that stuff only, the bank manager going to decide that whether he has applied for the next loan, like he'll or next apply ಮಾಡಿದಾಗ ಅವರು ಅದನ್ನು ರೀಪೇ ಮಾಡಬಹುದಾ ಅಥವಾ ಮಾಡಲ್ವಾ ಇದನ್ನು ಅನಲೈಸ್ ಮಾಡ್ಬೋದು. ಸೊ ದಟ್ ವೆದರ್ ಟು ಅಪ್ರೂವ್ ದಟ್ ಲೋನ್ ಅಪ್ಲಿಕೇಶನ್ ಆರ್ ನಾಟ್, ಹಿ ಕ್ಯಾನ್ ಡಿಸೈಡ್ ಇಟ್ ವೆಲ್ and to take the actions immediately. So that will all this, for all those purposes, this kind of technique will be helpful. Okay, so just solve this problem. Okay, so firstly we'll consider some whatever the important data set will be there. So those data set will be loaded to your code, and whatever the libraries which are needed to solve this data set will be imported. Okay, so we need this NumPy library as a basic one, and pandas library to read and for the data exploration purpose, and sklearn.model selection. So this is needed to split up our entire data set into a train set and a test set. Train test is used to train the model, and test set is to check the evaluate the model. Okay, so sklearn.tree is our decision tree classifier. So this is what your important library that you need to import, because here in this sklearn library we have our decision tree classifier model, pre-trained model. Okay, so and sklearn.matrix to check the accuracy of the model, and sklearn.tree to just look out how the tree will look. Okay, so this will be supported by some this library will be supported for some system with compatibilities quite matters for this specific library actually, that specific model actually tree. So it is not like it's not supported for all the systems. ಎಲ್ಲ ಸಿಸ್ಟಮ್ಗೂ ಸಪೋರ್ಟ್ ಆಗಲ್ಲ, ಕೆಲವೊಂದು ಸಿಸ್ಟಮ್ಗೆ ಸ್ವಲ್ಪ ರೆಸ್ಟ್ರಿಕ್ಷನ್ಸ್ ಬರುತ್ತೆ. ಓಕೆ, ಆ್ಯಂಡ್ ಡೋಂಟ್ ವರಿ, ಲೈಕ್ ಮೋಸ್ಟ್ ಆಫ್ ದ ಸಿಸ್ಟಮ್ಸ್ ವಿಲ್ ಗೆಟ್ ದ like it is get downloaded, and you will get the tree like structures after like building, after constructing the decision tree, how it looks. So that will be visually able to see using this library. Okay, so next I am going to read the data. Okay, balanced data, and this is what a data set. So since it is this data set is in a Excel format, okay, Excel format the data set. So we'll going to use the method called read_excel. So because pandas library, using this pandas library we can read multiple formatted files. Okay, so read XLX format allittu, spreadsheets format allittu andre we have to use that Excel read_excel method. So I have read the data, and just check out what will be the length of the data set. Okay, so that means we'll just know the size and shape. Okay, so what is the shape of the data set? Just check it out, just a sec. So the data set length is 100, is nothing but 100 samples are present. Data set shape is 100,5, but 1000 samples are present, and 5 columns, 5000 rows, 5 columns is nothing but 1000 samples, 5 features we have. And out of those 5 features, so what are the features, and which will act as a independent variable and which will act as a dependent variables, which will see that. So initial payment, last payment, credit score, house number, all are independent features, and what we are going to predict is yes or no, whether he is going to repay the loan, whether he is going to clear his loan or not. Okay, ಸೊ ಇನ್ಸ್ಟಾಲ್ಮೆಂಟಲ್ಲಿ ಪೇ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಪೇಮೆಂಟ್ ಮಾಡೋ ಬೇಸ್ ಮೇಲೆ ಅವ್ರಿಗೆ ಕ್ರೆಡಿಟ್ ಸ್ಕೋರ್ಸ್ ಇದೆ, ಯಾವ ಹೌಸ್ ನಂಬರ್ ಅಂತ ಇದೆ. ಸೊ ಅದ್ರ ಬೇಸ್ ಮೇಲೆ ಅವರು ರೀಪೇ ಮಾಡ್ಬೋದಾ ಲೋನ್ ಅಥವಾ ಇಲ್ವಾ, ಅದನ್ನು ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ವೆದರ್ ಎಸ್ ಆರ್ ನೋ. So since it is a class, yes or no, or a class, discrete classes that we are going to predict, so this comes under the classification problem, and we are going to use the decision tree algorithm to solve the problem, to solve this problem. Okay, so because the result is class, not the continuous value. Okay, so after reading out the data set, so we'll just explore it. So we'll just explore in the sense we have to check out whether is there any missing data is present, or or any categorical data is present, we just look after that stuff. So since as I said, decision tree algorithm can handle the categorical data as well, so we don't need to bother about the categorical data. Like we have to bother about whether the data contains a null values or not. Okay, so for that a simple method is we can use the isNull method. Okay, so by using isNull method we can just simply check out like is there any column is present with the null data. So since we didn't have any null values here, we will get the result values as 0. And afterwards, so isNull method na use ಮಾಡಿದ್ವಿ. isNull method use ಮಾಡಿದ್ರೆ ಯಾವುದಾದ್ರೂ null ಇದೆನಾ empty cell, so check ಮಾಡುತ್ತೆ, and dot sum will give you the total null values in your data set, like column wise. So data set ಅಲ್ಲಿ ಯಾವುದೇ null values ಇಲ್ಲ, you'll get the result as 0. So afterwards we'll just split out what can be the x, what can be the y. As I said, x will contain the independent variables or the input, y will contain the output or the dependent variable, or like target or the outcome. Okay, here what happens are just a sec, our column result will act as our independent variable, and rest of these will be acting like a independent variables. Okay, so independent variables will be as like so 0 to -1. So all the rows, so 0 to -1 is except the last column. How many columns are present, all will be treated as taken under x, and like only last column will be taken under y. So just afterwards we are going to split the data set into a trained set and a test set, independent train, independent test, dependent train, and dependent test. Okay, independent train test, dependent train test, we just split out this by specifying the size as 0.3. that means that 30% of the data will be used for the testing purpose and 70% of the data will be used for the training purpose. So afterwards just implement the decision tree algorithm by using decision tree classifier model. So decision tree classifier model na import ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. So ಅದರಲ್ಲಿ ಮೆಥಡ್ ನ ಕಾಲ್ ಮಾಡ್ತೀವಿ by specifying the criteria entropy. Here we can also find out, give it as a Gini or the information gain. Okay, so anything we can give. Okay, so for any criteria it will work. Okay, so whichever the criteria that you are going to give, based on that criteria the tree will be constructed. Okay, so afterwards it is going to be applied on the data set. Okay, so after that we are going to fit our, I'll just call the model method, and we'll give the needed parameters. Okay, and afterwards we are going to fit our training data set to the model. Okay, so by using this training data set, the tree will be constructed for the decision tree classifier algorithm, and afterwards we'll just predict the results. Okay, so afterwards we'll just predict the results for the testing values. So this is needed for evaluation, model evaluation. Okay, so ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, ಮಾಡೆಲ್ನ ಕಾಲ್ ಮಾಡ್ತೀವಿ, ಆಬ್ಜೆಕ್ಟ್ನ ಕಾಲ್ ಮಾಡಿಬಿಟ್ಟು ಆಬ್ಜೆಕ್ಟಿಗೆ ನಿಮ್ಮ ಡಾಟಾ ಸೆಟ್ ಇದೆ, ಟ್ರೈನಿಂಗ್ ಡಾಟಾ ಸೆಟ್ ಇದೆ, ಅದನ್ನು ಫಿಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ದಟ್ ದ algorithm will be feeded with the training data set, so that the algorithm or the machine is going to learn how the data is distributed in the data set. Okay, and afterwards we'll just predict the results by using the test data. So test data use ಮಾಡ್ಕೊಂಡು independent test data use ಮಾಡ್ಕೊಂಡು predict ಮಾಡ್ತೀವಿ result, and afterwards we'll just compare what is the predicted result from the model and what is the actual values in the data set. Okay, so for that purpose just use the accuracy score. Accuracy score will compare both the testing results. That means y test is nothing but about the actual values that we are having for the test data. Okay, independent test data ಗೆ ನಮಗೆ ಔಟ್ಪುಟ್ ಏನು ಬಂದಿತ್ತು, ಅದು ಆ್ಯಕ್ಚುಯಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಏನಿದೆ ನಮ್ಮ ಡಾಟಾ ಸೆಟ್ಟಲ್ಲಿ, ದಟ್ ಈಸ್ ಸ್ಟೋರ್ಡ್ ಇನ್ y test, and y pred is the values calculated from the model. Okay, we'll just compare this, ಎಷ್ಟು ಎರಡನ್ನೂ ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ. ಆ ಮಾಡೆಲ್ ಆ್ಯಕ್ಚುಲಿ ಏನು ವ್ಯಾಲ್ಯೂ ಕೊಡ್ತಾ ಇದೆ, ಬಟ್ ಆ್ಯಕ್ಚುಲಿ ರಿಯಲಿ ಇರೋ ವ್ಯಾಲ್ಯೂಸ್ ಏನಿದೆ ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಕಂಪೇರ್ ಮಾಡಿಬಿಟ್ಟು ಅದರ ಅಕ್ಯುರಸಿ ಎಷ್ಟು ಬರುತ್ತೆ ಚೆಕ್ ಮಾಡ್ತೀವಿ. ಸೊ ವಿಲ್ ಗೆಟ್ 93.7 ಅಕ್ಯುರಸಿ. ನನಗೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಕೆಲವೊಂದು ವ್ಯಾಲ್ಯೂಸ್ ಮೇ ಬಿ ಮಿಸ್ ಆಗಿರುತ್ತೆ, ಅದು ಎಷ್ಟು ಪರ್ಸೆಂಟ್ ಮಿಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ವಾಟ್ ಹಿಯರ್. ಸೊ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ 93.7% accurate result, accurate model. Okay, so afterwards we are going to use it for the deployment. Okay, so this is how our decision tree will going to work. Okay, so this is how our decision tree will going to work, and thereby the manager is going to predict and find out is there any customers are going to return the loan so they are took from the bank or not, so it will going to identify. Okay, so thereby he can decide what action to be taken afterwards. Okay, so here is, this is what our actual problem statement to predict if the customers will pay a loan amount or not using the loan or not, so using the decision tree algorithm in Python. Okay, so series of steps you are going to perform. Okay, fine. So that is how we are going to implement our decision tree algorithm. Okay. That's what the stuff is all about, the decision tree algorithm, and we have discussed about the advantages and disadvantages also. Okay, so that's what about decision tree algorithm. You like one kind of classification problem solving technique. Okay, in machine learning just need to import the dataset and need to train the model, and we can check out the accuracy of the model. Afterwards we can deploy them. Okay, whatever the models in real time that you are going to use for the predictions, for the classifications, so all those stuffs that can be like behind that technique, behind that you may see some apps, right? ಜಸ್ಟ್ ಈಗ ಆ್ಯಪ್ಸ್ನ ನೋಡಿರ್ತೀರ ಅಥವಾ ಸಾಫ್ಟ್ವೇರ್ಸ್ನ ನೋಡಿರ್ತೀರ, ನಿಮಗೆ ಇನ್ಪುಟ್ ಡಾಟಾ ಏನು ಕೊಟ್ಟರೆ ಸಾಕು ನಿಮಗೆ ರಿಸಲ್ಟ್ ಬಂದುಬಿಡುತ್ತೆ. ಆ ರಿಸಲ್ಟ್ ಬರೋದಕ್ಕೆ ಮುಂಚೆ, ಆ ರಿಸಲ್ಟ್ ಆ್ಯಪಿಗೆ ಕೊಟ್ಟರೆ ಅಥವಾ ಸಾಫ್ಟ್ವೇರಿಗೆ ಕೊಟ್ಟರೆ ಅದು ಬರೋದಕ್ಕೆ ಮುಂಚೆ ಏನು ಆಗ್ಬೋದು ಬ್ಯಾಕ್ಗ್ರೌಂಡಲ್ಲಿ, ದಟ್ ಈಸ್ ವಾಟ್ ಯುವರ್ ಇಂಪ್ಲಿಮೆಂಟೇಷನ್ ಹಿಯರ್, ಲೈಕ್ ವಾಟ್ ಎವರ್ ಐ ಹ್ಯಾವ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಟಿಲ್ ನೌ. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ದ ಸ್ಟಫ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾಪನ್ ಇನ್ ಬ್ಯಾಕ್ಗ್ರೌಂಡ್. ಇದೆಲ್ಲ ಆದಮೇಲೆ ಮಾಡೆಲ್ ಟ್ರೈನ್ ಆದಮೇಲೆ ಎವ್ಯಾಲ್ಯೂಯೇಟ್ ಆದಮೇಲೆ ಅದನ್ನು ಡಿಪ್ಲಾಯ್ಮೆಂಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ ಡಿಪ್ಲಾಯ್ಮೆಂಟ್ ಫೇಸಲ್ಲೇ ಎಂಟೈರ್ ಏನಿದೆ ಇನ್ಪುಟ್ ಏನು ಕೊಡ್ತೀರಾ, ಹೊಸದಾಗಿ ಇನ್ಪುಟ್ ಯಾವ ಹೊಸ ಕಸ್ಟಮರ್ ಬರ್ತಾರೆ ಅವ್ರ ಡಾಟಾ ಏನಿದೆ ಅವ್ರು ರೀಡ್ ಮಾಡ್ತೀರಾ, ಅದನ್ನು ಇನ್ಪುಟ್ ಆಗಿ ಕೊಡ್ತಾರೆ. ಇನ್ಪುಟ್ ಕೊಟ್ಟರೆ ಅವ್ರು ಪೇ ಮಾಡ್ತಾರೋ ಇಲ್ವೋ ಅಂತ ನಿಮಗೆ ರಿಸಲ್ಟ್ ಬರುತ್ತೆ. ಇಲ್ಲಿ ಪೇ ಎಸ್ ಆರ್ ನೋ, ಇಲ್ಲಿ ರಿಸಲ್ಟ್ ಬಂದುಬಿಡುತ್ತೆ. ಅಲ್ಲಿ ನೀವು ಯಾವುದೇ ಕೆಲಸ ಏನು ಮಾಡೋದಿರಲ್ಲ, ಆ ಕೆಲಸನ ಏನು ಮಾಡುತ್ತೆ ಮಷಿನೇ ಮಾಡುತ್ತೆ. ಆ ಮಷಿನಿಗೆ ಆ ಮಷಿನ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ದಿಸ್ ಇಸ್ ವಾಟ್ ದ ಸ್ಟೆಪ್, ಸೀರೀಸ್ ಆಫ್ ಸ್ಟೆಪ್ಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಡೂ. ಓಕೆ, ಮಷಿನ್ ಕಲಿಯೋ ಹಾಗೆ ನಾವು ಮಾಡಬೇಕು. ಸೊ ಅದನ್ನು ನಾವಿಲ್ಲಿ ಮಾಡಿದ್ವಿ. ಓಕೆ, so that's all about the decision tree algorithm. So in the next session we'll going to discuss about some more algorithms, some more classification or the clustering kind of algorithms. Okay, similarly we can implement similarly you can implement the random forest algorithm, because the random forest algorithm is nothing but your decision tree only. But what happens there, instead of one tree construction, there plenty of trees will be constructed. Okay, many trees will be many decision trees will be constructed for a single data set, and out of those decision tree which class will be for a new sample input, like how many classes, like how many decision trees will give the will vote for one class more. Okay, so the multiple decision random forest algorithm ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಮಲ್ಟಿಪಲ್ ಡಿಸಿಷನ್ ಟ್ರೀಸ್ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನಿಮಗೆ ಒಂದೇ ಡಿಸಿಷನ್ ಟ್ರೀ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಆಗಿದೆ. ಬಟ್ ರ್ಯಾಂಡಮ್ ಫಾರೆಸ್ಟಲ್ಲಿ ರ್ಯಾಂಡಮ್ ಫಾರೆಸ್ಟ್ ಅಲ್ಗಾರಿದಮ್ನ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಿದರೆ ಒನ್ ಡಾಟಾ ಸೆಟ್ಟಿಗೆ ನಿಮಗೆ ಮಲ್ಟಿಪಲ್ ಡಿಸಿಷನ್ ಟ್ರೀಸ್ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ ಮಲ್ಟಿಪಲ್ ಡಿಸಿಷನ್ ಟ್ರೀಗೆ ಲೈಕ್ ನೀವು ಹೊಸ ಸ್ಯಾಂಪಲ್ ಯಾವುದೋ ಕೊಟ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ ಅದರಲ್ಲಿ ಎಷ್ಟು ಲೈಕ್ ಮೆಜಾರಿಟಿ ವೋಟ್ ಯಾವ ಕ್ಲಾಸಿಗೆ ಬರುತ್ತೆ. ಆ ರ್ಯಾಂಡಮ್ ಫಾರೆಸ್ಟ್ರಿ ಅಲ್ಗಾರಿದಮ್ನ ನೀವು ಆ ಡಾಟಾ ಸೆಟ್ಟಿಗೆ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಹೊಸ ಸ್ಯಾಂಪಲ್ಲಿಗೆ ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡಬೇಕು ಅಂದಾಗ ನಿಮಗೆ ಆ ಮಲ್ಟಿಪಲ್ ಟ್ರೀಸ್ ಏನು ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಆಗುತ್ತೆ, ಆ ಮಲ್ಟಿಪಲ್ ಟ್ರೀಸಲ್ಲಿ ಯಾವ ಒಂದು ಕ್ಲಾಸಿಗೆ ನಿಮಗೆ ಮೆಜಾರಿಟಿ ಆಫ್ ವೋಟ್ಸ್ ಬಂದಿರುತ್ತೆ, ಅಂದರೆ ಯಾವ ಒಂದು ಕ್ಲಾಸು ಮಲ್ಟಿಪಲ್ ಟ್ರೀಸಿಂದ ಒಂದು ಕ್ಲಾಸು ಜಾಸ್ತಿ ಪ್ರೆಡಿಕ್ಟ್ ಆಗ್ತಾಯಿದೆ. ಈಗ ಆ್ಯಪಲ್, ಬನಾನಾ, ಆರೆಂಜ್ ಅಂತ ಬಂದರೆ ಈಗ ಆ್ಯಪಲ್ಗೆ 3 ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಟ್ರೀ, 3 ಡಿಸಿಷನ್ ಟ್ರೀ ರಿಸಲ್ಟ್ ಬರ್ತಾ ಇದೆ. ಬನಾನಾ ಅಂತ 1 ಡಿಸಿಷನ್ ಟ್ರೀ ರಿಸಲ್ಟ್ ಕೊಡ್ತಾ ಇದೆ, ಆರೆಂಜ್ ಅಂತ 1 ಡಿಸಿಷನ್ ಟ್ರೀ ರಿಸಲ್ಟ್ ಕೊಡ್ತಾ ಇದೆ. ಸೊ ಅವಾಗ ನೀವು ಅವಾಗ ರ್ಯಾಂಡಮ್ ಫಾರೆಸ್ಟ್ ಕ್ಲಾಸಿಫೈರ್ ಅಂತ ನಿಮ್ಗೆ ರಿಸಲ್ಟ್ ಬರೋದು ಆ್ಯಪಲ್ ಅಂತ, ಬಿಕಾಸ್ ಮೆಜಾರಿಟಿ ಆಫ್ ದ ಟ್ರೀಸ್ ವಿಲ್ ಗಿವ್ ಯು ದ ಆ್ಯಪಲ್ ಆಸ್ ಅ ಕ್ಲಾಸ್ okay, for the new sample. Okay, so thereby it will going to decide that class is apple. Okay, so this is what the stuff will going to happen behind random forest algorithm. In the similar way you can implement the random forest algorithm also. Okay, so here is just an example. Okay, we just use the sample like based on the gender, age and estimated salary we have to predict whether he is going to purchase a particular product or laptop or not. Okay, So for this data set we have implemented the series of steps that we are going to follow in case of any machine learning algorithm, like data pre-processing phase, data model, train, test, split, or all the steps. So after that we just implement random forest algorithm. Okay, so random forest algorithm, so similar way, scale learn, so just use ensemble instead of just tree here. Okay, so just a second. Instead of just a tree here, we are going to have like, instead of just tree here, we are going to have it like ensemble random forest classifier, similar to like decision tree classifier. We'll just give the criteria here as entropy, because it is going to create the trees, and number of estimates number of consideration of trees. Out of 10 trees, 10 decision trees decision tree construct ಆಗುತ್ತೆ. 10 decision tree construct ಮಾಡಿ ಅದರಲ್ಲಿ ನಿಮಗೆ ಮೆಜಾರಿಟಿ ಕ್ಲಾಸ್ ಯಾವುದಕ್ಕೆ ಬರುತ್ತೆ ಅದನ್ನು ಯಾವುದು ಕೋಡ್ ಬರುತ್ತೆ ಅಥವಾ ಮೋಸ್ಟ್ ಫೇವ್ರೇಟ್ ಮೋಸ್ಟ್ ಪಾಪ್ಯುಲರ್ ಕ್ಲಾಸ್ ಯಾವುದು ಬರುತ್ತೆ ಆ ಕ್ಲಾಸ್ನ ರಿಸಲ್ಟ್ ಆಗಿ ಕೊಡುತ್ತೆ. Okay, so this is what the stuff will going to happen in case of random forest algorithm. Okay, and that is how you can solve multiple problems, either regression problem or a classification problem, using a different algorithms which are available in any machine learning field. We have plenty of more than 80 to 100 algorithms will be present in machine learning, which are already defined, and it's not like we have to use only the predefined models or predefined training or classification algorithms or the decision tree algorithms. It's that you can also build your own algorithm and you can implement that, you can use that as a model. Okay, there's a scope for that. Okay, but these are all the stuff it is already built by some other else. Okay, and developed by some other else, and there's a chance for you also that you can also construct your algorithm and work on it, and you can introduce that, you can upload that as a new algorithm also, because if it is giving more accuracy than any other algorithm, ಬೇರೆ ಯಾವುದೇ ಅಲ್ಗಾರಿಥಮ್ಗಿಂತ ನಿಮ್ಮ ಅಲ್ಗಾರಿಥಮ್ ನೀವೇನೋ ಸೀರೀಸ್ ಆಫ್ ಸ್ಟೆಪ್ಸ್ ಯಾವುದೋ ಈ ಫಂಕ್ಷನ್ ಅಥವಾ ಯಾವುದೋ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಪ್ರೇಷನ್ ಅಪ್ಲೈ ಮಾಡ್ತೀರಾ ಅಥವಾ ಪರ್ಟಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡ್ತೀರಾ, ಅಲ್ಲಿಂದ ನಿಮಗೆ ರಿಸಲ್ಟ್ಸ್ ಚೆನ್ನಾಗಿ ಬರ್ತಾಯಿದೆ. ನೀವು ನಾರ್ಮಲಿ ಬೇರೆ ಎಲ್ಲ ಅಲ್ಗಾರಿಥಮ್ಸ್ಗಿಂತ ನಿಮ್ಮ ಮಾಡಲ್ ನಿಮಗೆ ಅಕ್ಯುರಸಿ ಚೆನ್ನಾಗಿ ಬರ್ತದೆ. ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಯೂಸ್ ದೆಮ್, ಯು ಕ್ಯಾನ್ ಪೋಸ್ಟ್ ಇಟ್ ಆನ್ ಪಬ್ಲಿಕ್ ಚಾನಲ್ಸ್, ಪಬ್ಲಿಕ್ ಸೈಟ್ಸ್. Okay, and let anybody others also use them. Okay? So do work on it. I'll upload some more data sets in the classroom. Okay, so and work on that by implementing the same algorithms like decision tree or the random forest or the k-nearest neighbor algorithm or a linear regression problem. So I'll upload some more data sets in the classroom. Just work on those and solve those, and do concentrate on the data pre-processing phase more, and while selecting the like training and testing portion. So and which feature will act as a dependent feature, like, or the which columns you have to consider for independent variables, like for x and for y. So that has to be taken care of. Okay, and that's what for today's session. So we shall discuss next stuffs in the next session. Okay, that's it. Thank you.